Alright, here we go. So here's a quick video for you on what we do with this exponent situation like this. Um, the biggest concern or piece to think about here with this problem is like, how do I get rid of this? I mean, I need to access what's inside of these parentheses to be able to solve for x. So how do I get rid of this 1/3 power? And what my introduction to this is that what I want you to realize is that, like, and I'm just kind of changing for an example here. If I had x to the 3/4 power is equal to 10, all these numbers are made up, it has no relationship to anything. If I wanted to eliminate that exponent, I have to go back and reflect upon the properties of exponents. And so in this case here, if my exponent, if I multiplied by 4/3, my property says that if I have a power raised to a power, then I take those two powers and I multiply them together. And so this would become x to the 12/12, which is actually equal to x to the, excuse me, sorry about that, which is actually equal to x to the first power. Well, just like algebra, our whole entire life, whatever you do to one side, you have to do the exact same thing to the other side. And so at this point, this becomes 10 to the 4/3. And now you pull out your calculator, and I don't have my calculator opened up, I'll have to open it. But I pull out my calculator and I type in 10 to the 4/3 power, and that tells me what x is. So the moral of the story is that if I want to undo a rational exponent, I multiply by the reciprocal. So the key word here is reciprocal. Sorry about that, I can't spell. Procal. Okay, so look at my reciprocal. So when I come over to this guy and I start him off and I have x squared plus 12x raised to the 1/3 power is equal to 4. Well, in this case right here, I'm going to raise this entire thing to the 3/1, the reciprocal of 1/3. So in that case there, my 3's cancel, my 1's cancel, and I mean, or you could go ahead and write it out. I mean, you end up getting x squared plus 12x, and then if you want to write it out and see it, it would be 3/3. But you can also just cancel it. Just like over here, we could have said, well, we got a 4 on the bottom and a 4 on top, and a 3 on the top and a 3 on the bottom, and they'll cancel and turn into a 1. So that's kind of just shortcutting to it. Whatever I do to one side, I have to do to the other. Let me hit pause and okay, so sorry about that. I got my calculator back. So at this point, I'd say to myself, okay, I've got 4 raised to the and 3 divided by 1 power. And so I find out that on the right-hand side, this is equal to 64. On the left-hand side, remember this 3/3 cancels, so when I come down my next step, I really just have x squared plus 12x equals 64. At this point, what I would hope is that you see that you have a quadratic equation. And so when you look at it and you're saying, okay, well, a quadratic equation, that's where I have ax squared plus bx plus c is equal to 0, and say, oh, wait a second, I'm not equal to 0, so I need to go ahead and move this 64 over to the other side. At this point, this leaves me with x squared plus 12x minus 64 is equal to 0. Now, you could use factoring, you could use guess and check factoring, you could use bottoms up factoring. For the sake of just being consistent, for myself, I'm going to use the quadratic formula, which is not the fastest method, but because this is an online crash course, B term, I'm not going to focus on other outside techniques. I'm going to keep it straightforward. So the quadratic formula says that if I wanted to find x, right here, what makes this true if I wanted to factor this guy, essentially, that I would plug in my a, my b, and my c. So from this guy, we have a is equal to 1, there's a 1 right there, understood 1. B is equal to 12, and C is equal to negative 64. So we use those terms, we plug them into our quadratic formula. So we have the formula says negative b plus or minus the square root of 12 squared minus 4 times a times c all over 2 times a. At this point, I go through and I start simplifying. If you watched my previous video, I told you guys to go ahead and do what's under the radical first. So pull out your calculator and see what you get under the radical. So we have 12 squared minus 4 times 1 times negative 64. Under the radical, we get negative 12 plus or minus the square root of 400 divided by 2. Well, I believe the square root of 400 is actually a perfect square, so I take the square root of 400, and sure enough, so at this point, I'm left with x is equal to negative 12 plus or minus 20 divided by 2. Now recall that gives me two possible solutions, so I'm going to go ahead and I could simplify this right now, but I'm going to go ahead and break it off into the two solutions, the addition and the subtraction. So I have negative 12 plus 20 divided by 2, and we have negative 12 minus 20 divided by 2. So in this case here, that's going to be 8. 8 divided by 2 is 4. In this case here, that's going to be negative 32. Negative 32 divided by 2 is negative 16. So the confusing part about this is that I don't have my factors right now. I have my solutions. So I have x is equal to 4, and I have x is equal to negative 16. So when I go backwards into my factors, I have to have that understanding that this is actually going to be x minus 4, and this is going to be x plus 16. But the deal is that this is what they're looking for. So now we pull up the original problem, and we think about what they're asking. Solve this solution. What are the numbers that we can place inside of here that will be equal to 4? And when I go and I look at the your actual question, which you said the answer is 4. Well, you're right. The answer is 4. But that's only one of the solutions. You have two solutions. You have 4 and negative 16, because both of those numbers will work. If I plug them in and I simplify this, I will get the right numbers. I'll get that solution of 4. So I think you see why 4 works. Let me show you why negative 16 works. So open parentheses, just like put a negative 16, close squared, oops, plus 12 times negative 16, close off, raise that to the 1/3 power, and the question is, will this equal 4? And sure enough. So there's two solutions is the problem of what you run into in your particular case. Hope this helps you out. Let me know if you have any questions.